All right, I'm going to do a video going over this review for you. Hopefully it will help you if you're stuck on anything for tomorrow's quiz. So the first question, the group of questions, asks you to determine whether the inverse of f is a function and explain. You need to make sure you're following directions, because if it asks you to explain, you're going to get marked off if you don't explain. So to determine whether an inverse is a function, we use the horizontal line test. If a horizontal line touches the graph more than once, the inverse is not a function. So if it passes the horizontal line test and it only touches once, then the inverse is a function. Now you are expected to know what these graphs look like without actually making a table. In general, the square root graph looks like this. The x squared graph is negative, so it's an upside down parabola. The 5 minus 7x, this is linear, so it's negative, linear, a negative line, and the absolute value function is a v. That's all you really need to know to answer these questions. So now let's look at a vertical line or horizontal line. Now remember, the vertical line test tells us whether this function we're looking at, or this equation we're looking at, is a function. The horizontal line test gives us information about its inverse. So a horizontal line, if you took it and passed through the whole graph, it's never going to touch more than once. So the first function, number 1, passes our vertical line test. So yes, it passes the HLT. I'll abbreviate for my video here. The second graph, the upside down parabola, crosses a horizontal line twice. So the answer is no, because it does not pass the HLT. The HLT. The next one, the line, if I keep drawing horizontal lines, it's only going to touch it once. So yes, the inverse will be a function because it passes the horizontal line test. And then the last one touches the horizontal line twice. So no, it does not pass our horizontal line test. And you want to write those sentences out. I just don't have space. The next set of equations asks us to use the rules of exponents to simplify. It may not always give you that clue. So you have to recognize when you have similar bases. In number 5, the base is the y. In number 6, the base is the x. And you have all these exponents, you're probably going to use your exponent rules. And our exponent rules tell us if we're multiplying powers, we need to add our exponents. And in order to add 4/3 plus 5/6, we need a common denominator. And the common denominator here would be 6, so I'm going to multiply the 4/3 by 2. Let me give myself some space here. So multiply by 2 on top and 2 on the bottom. So we get 8/3 plus, or I'm sorry, 8/6 plus 5/6 equals 13/6. Now that's not my answer, that's my exponent. So y to the 13/6 power is my final answer. As a general rule, if our equation, our first initial problem starts out with exponents and exponentials and rational exponents, our answer needs to have that. If it starts out with radicals, then our answer should have radicals in it. Number 6 is the same thing, asking us to use our exponent rules. So for the numerator, we're going to add. We get 3/8 plus times by 2 on the top and the bottom there. We get 6/8. So we have 9/8 minus the fraction on the bottom, 1/6. When we divide, we're subtracting our exponents. So let's get a common denominator here. It's times by 4 and times by 3. That way I get a common denominator of 24. So I get 27/24 minus 4/24. That's a minus. So we get 23/24. So our final answer is x to to the 23 over 24th power. That's really hard to write on here, real that small. Okay, so that's our answer for number 6. So if you need to back this up, I'm going to clear this off so I have space to do the next couple. All right, let's look at number 7 here. Number 7 always seems to stump people, and we have lots of ways to solve this. So the way I'm going to do it right now isn't necessarily the only way to solve this. But one of the things people like to do is get rid of their negatives. Some people like to apply the negative 3 power first. I'm just going to simplify what I've got. I'm going to leave all the negatives there, and then I'll deal with them in the bottom. At the very end, I'll make sure there's no negative answers. So I have 14 divided by 8. Those are numbers. We treat them the same. They're both divisible by 2. So I get, let's see, 7 over 4. So my numerator is going to have a 7 in it. My denominator is going to have a 4. Now, a to the negative 4th power divided by a to the negative 2, I subtract my exponents. So negative 4 minus negative 2, I'm going to change that to plus a positive, so I get negative 2. A to the negative 2 power. Now I know we don't want negatives in our answers, but we'll get there. Hold on. B to the 6th. B to the 6th divided by b to the negative 4. I'm going to subtract my exponents. So I get 6 minus negative 4. That becomes plus. So we get b to the 10th. And then c to the 5th. And there's no c on the bottom. So I just leave the c to the 5th. And this is all being raised to the negative 3 power. Now the negative 3 power is going to take 7 to the negative 3rd and put it in the denominator. 7 cubed is 343. It moved from the top to the bottom because it's a negative 3. And 4 to the negative 3rd power moves it from the bottom to the top, which is a 64. And then I multiply my exponents when I raise a power to a power. So I have a power raised to a power. I'm going to multiply negative 2 times negative 3. I get a to the 6th. B to the negative 30, right? 10 times negative 3 is negative 30, so I'm going to put b to the positive 30 in the denominator because the negative exponent means it goes in the denominator. And c to the 5th to the negative 3, again, I multiply 5 times negative 3. I get c to the 15th in the denominator. And that's my final answer there. Let's look at number 8. 6x to the negative 4y squared over 4x cubed times 15x to the 4th y to the 11th over 12x to the negative 2y to the negative 3. So we have a lot going on, but the first thing I see is that 6 can cancel the 12 twice. And 2 doesn't go into 15, and 4 doesn't go into 15, so that's going to stay. I can subtract my exponents again. The x to the negative 4 divided by x cubed, that's negative 4. We'll do it up here. Negative 4 minus 3, so that's going to be negative 7. So I'm going to put x to the positive 7 in the bottom. And there's no other y to cancel here, so y squared. And my 6 canceled with the 12, but I'm still left with a 4 in the denominator. On the second fraction, I still have the 15, and I have the 2 in the denominator. I get x to the 4th. X to the 4th divided by x to the negative 2, so that's 4 minus negative 2 becomes plus positive, so that's x to the 6th. Positive, so it goes in the top. And then I have 11 minus negative 3, so that's 11 minus a negative. So that becomes plus 14, y to the 14th. So now we'll combine the two fractions together. We'll start with the numbers 15 on the top in the numerator and 8 in the denominator. My numerator has y squareds in it, so y squared has y's. So y squared and y to the 14th. Add your exponents, so we get y to the 16th power. And then I'm going to subtract 6 minus 7 for my x's. My x's here here, and here. I have more in the denominator, so that means I'm going to end up with x to the 1 in the denominator because 6 minus 7 is -1, and that stays in the denominator. So my final answer, 15 y to the 16th over x to the 8th. And that's the final answer for number 7. Okay, we're moving on to numbers 10 and 11. Number 10 is dividing a radical binomial. 4 divided by -3 plus the square root of 7. I'm going to do this, we multiply by the complex conjugate, or not the complex conjugate, the conjugate of the denominator, which would be -3 minus square root 7. So multiply by -3 minus square root 7. The numerator, I'm just going to distribute 4 times -3, -12. 4 times negative square root 7 is -4 square root 7. I don't multiply it into it, it just goes in front. And in the bottom, I have to do some foiling here. I get -3 times -3 is +9. -3 times negative square root 7 is +3 square root 7. And square root 7 times -3 is -3 square root 7. Notice that these cancel. That's why we multiplied by the conjugate. And then minus the square root of 7 times the square root of 7, or the square root of 7 times negative square root of 7. So remember, that becomes negative square root of 49, which is a step you can skip because that just equals 7. So my denominator ends up being 9 minus 7, which is 2. And then I can simplify this. -12 divided by 2 is -6. And -4 divided by 2 is 2. So I get -6 minus 2 square root 7 as my final answer. Okay, I just realized that I skipped number 9. So let me do that on here real quick. Number 9 was 9 divided by 9 to the 1/3 power. Again, we're using rules of exponents. So my numerator of the exponent is 1. 1 minus 1/3. 1 is 3 over 3 minus 1/3, which is 2/3. So my answer is 9 to the 2/3 power. Okay. All right, now let's look at number 11. In order to add and subtract radicals, I have to have the same radicand, the number under the radical, and I have to have the same index, the root number. So I need to have, I can probably get my cube roots to be the same, and I could probably get my square roots to be the same. So what I need to do in order to do that is simplify each root. So 24 is 8 times 3, and 8 is 2 times 2 times 2 times 3. It's a cube root, so I want 3 of them. I'm going to take those 3 out. -3 times 2 cube root of 3. And I multiply the numbers in front, so -6 cube root 3. Let's see, 18 is 9 times 2, which is 3 times 3 times 2 with the square root. I'm looking for 2's. Pairs, so that's plus 9 times the 3 comes out, the 2 stays in the radical, so plus 27 radical 2. 32 is 16 times 2. Well, the square root of 16 is 4. That's 4 and 4. So there's my 2's, or my doubles. So minus 2 times 4 square root of 2. So minus 8 square root 2, and then plus the cube root of 3. Now I'm going to find my common terms. I have cube root of 3 and a cube root of 3. So my answer here, when I add up -6 cube root of 3 plus the cube root of 3, that's plus 1 cube root of 3. So -6 plus 1 is -5 cube root of 3. And then I have my square root 2's, so I have 27 minus 8, which is going to give me a positive 19 square root 2, and that's my final answer for number 11. All right, let's look at 12 and 13. Number 12 and 13 are different. They look like they're the same, but they're really not. Number 12 is a radical binomial, having two terms separated by addition or subtraction. Number 13 are just radicals being multiplied together. The 2 is being multiplied by the radical 4, and this 2 is being multiplied. You still need to have the same radicals to combine them. So these are both square roots, which is good, and these are both fourth roots. So we have 4 minus 3 square root 5 times 2 plus 6 square root 5. I'm going to have to use FOIL or the vertical multiplication that I often do in class. So I'm going to put my 2 plus 6 radical 5 underneath and multiply vertically like you would any other number. So first I'm going to multiply by the square root 5 times the square root 5. Square root 5 times square root 5 is just 5. And so this is going to become 18, negative 18 times 5. So that's going to be 90 later on. And then now I'm going to multiply the 6 radical 5 times the 4. When I do that, I just multiply the numbers in front because the 4 is not under the radical. So I get 24 radical 5. Then I'm going to multiply my 2 times my negative 3 radical 5. Again, I multiply the numbers in front. So I get minus 6 radical 5. And lastly, I multiply my 4 times my 2. So I get 8. So I get 8 minus 18 square root 5 minus 90. And 8 minus 90 is negative 82 minus 18 square root 5. Now that's going to be very different from how we do number 13, and the difference is the addition and subtraction sign. So for number 13, I'm going to multiply the numbers in front, negative 4, and then I'm going to multiply what's under the radical. But instead of actually spending the time to multiply out 36 by 72 and then break it all down again, I'm just going to start by breaking it down. 36 is 6 times 6, and 72 is, let's see, 8 times 9. Okay, if that's how we are thinking about it first. So 6 times 6, 3 times 2, and 3 times 2. 8 is, what did I do that for? 8 is 2 times 2 times 2. And 9 is 3 times 3. So remember that with a fourth root, we're looking for 4 of a number. So I have 1, 2, 3, 4 threes. So I'm going to bring that out. I'm going to write it in yellow here. 3, that comes out of the radical. And then I have 1, 2, 3, 4 twos. And so that 2 is going to come out of the radical. And what I've left out front was this 4 that started, and the fourth root of, what's the only thing not circled in here? If we look, those are all circled. There's a lonely little 2 there that didn't get included in the party. So this 2 is going to stay under the radical. So the 2 stays under. And now I multiply what I have out front. Negative 4 times 3 times 2, that's negative 12 times 2, negative 24. Fourth root of 2. Okay, then I'm going to do number 14 and 15. I'm not going to take a picture of them, I'll just write them down. So we have number 14 here. The fifth root of 3y divided by the fifth root of 8x squared. So the first thing I like to ask myself when I have fifth roots on top and bottom is there anything I can do to simplify and make the numbers smaller? And that answer is no, there really isn't. So I'm just going to continue with rationalizing the denominator. I'm going to start by looking at this as 3y on top And I can write 8 as a power of 2, and that'll help me figure out how many more I need to multiply by. So if I have a fifth root, we need groups of 5 to get them out of the root. So what am I going to multiply by? If I have 3 2's already, now I need 2 more to get a total of 5 2's. So together, this gives me 2 to the 5th power. And then if I have x squared, I need 3 more x's to make that x cubed. And whatever I do to the bottom of the fraction, I must do to the top of the fraction. So when I multiply these together, 2 squared is 4, 4 times 3 is 12. So my numerator here is a fifth root of 12, and x cubed y. And then in the denominator, I end up with 2 to the 5th and x to the 5th, and the fifth root of 2 to the 5th and x to the 5th is 2x. So my final answer is the fifth root of 12x cubed y divided by 2x. And the last one that I'm going to do for this video here, the last one I'm going to do for this video is number 15. The cube root of 5 divided by 9n. And again, I like to see, can I do any simplifying? And the answer is no, so I'll write it the cube root of 5 over the cube root of, I'm going to write 9 as 3 squared n, so it helps me figure out how many I need. This is a cube root, so that means I need 3 of whatever I have to get it out of the radical. So if I already have two threes, I need 1 more, and if I already have 1 n, I need 2 more. So I have to multiply the denominator by the cube root of 3n squared. And whatever I do to the denominator, I have to do to the top, 3n squared. So I have the cube root of 15n squared in the numerator. And remember, when we multiply this together, we end up with 3 cubed n cubed. That was the whole point. So that when I take the radical of the bottom, I get 3n. And that's the final answer for number 15. Okay, I have a few more minutes to do a couple more problems. So I'm going to look at number 16. 16 up here. The 6th root of negative 2 to the 42nd power. We don't want you multiplying negative 2 to the 42nd power. This is no calculator quiz. So we want you to use the shortcuts, but understand when the absolute values are necessary. This instruction says simplify using absolute values when appropriate. So remember, the absolute value rule is when it's an even index and the answer comes out odd, it needs absolute value. So let's see if that's the case here. If I'm dividing 42 by 6, I get 7. So negative 2 to the 7th power. This even index here came out as an odd power, so I need an absolute value around that. And the absolute value of negative 128 is 128. So that's your answer for number 16. Number 17, the cube root of negative 64, a to the 21st power, b to the 32. So we're going to start and take the cube root of the number. Okay, that doesn't ever change. So I'm taking the cube root of negative 64, which is negative 4. And then I'm going to take the cube root of a to the 21 power. Our shortcut on that is to divide the exponent by the index. So 21 divided by 3, right? 21 divided by 3 is 7. So I just get a to the 7th. But 3 doesn't go into 32 evenly, so we have to look at it like 3 goes into 32 10 times remainder 2. So that means we're going to have some b's left under the radical. And that b is going to come out to the 10th power, and the cube root of b squared, the remainder, stays underneath the radical, and then the number of times it goes in evenly becomes the exponent on the number outside. Now this was an odd radical, right? This is a cube root, so I don't have to worry about absolute value because it only applies to the even index. Number 18, I have the fourth root of 256 x to the 38 y to the 17th. So the fourth root of 256 is, you should know these. If you don't know these by now, you're going to have a hard time on the test tomorrow. I mean, you could break it down, but you really should have some of the basic ones down. The fourth root of 256 is 4. 4 goes into 38, so we're going to do that again. 4 goes into 38. How many times? 9, remainder 2. So I get x to the 9th. And then inside my radical stays x squared. And then 4 goes into 17. 4 times remainder 1, so y to the 4th. And then 1y stays inside. Now, do I have a situation with an even index? Yes, I do. So now we have an even index, so I need to think about, do I need absolute value? So I'll look at my variables. X has a X has an odd exponent on it. Y has an even exponent on it. So it's the x to the 9th that needs the absolute value. Even index, odd power coming out, it needs the absolute value. And let me make some room here. All right, let's look at number 19. The sixth root of negative 216, a to the 6th, b to the 24th. So it's an even root, so we're going to have to think about absolute values in that. What is the sixth root of 216? Okay, let's investigate this 216. I believe if I divide it by 3, 3 goes into 21 7 times, and 3 goes into 6 twice. And that's 8 times 9 times 3, 2 times 2 times 2, times 3 times 3 times 3. 216 cannot be simplified. But why am I doing that? I missed the main part of this problem, the fact that we have a negative that's not being raised to a power underneath an even root. So I'm doing all this work for nothing. It's no solution. And number 20, square root of 12, x squared, y to the 15th. So 12 is 4 times 3. That's 2. Keep this 3 under the square root. The square root of x squared is x. The square root of y to the 15th. 15 divided by 2 is 7. So y to the 7th. Remainder 1. 1y stays underneath. Now, is this an even radical? It's an even index. Remember that if it's not written, it's a 2 right here. So do I need an absolute value? And where do I need it? I need it around both the x and the y because they both have odd exponents. All right, guys, that's as much as I have time for right now. I hope that this first 20 problems helps you on the test tomorrow.